which is having a resistance R. Lambda be the resistance per unit length. So which is at a distance A, let this be side length is L. What is EMF induced? What is the expression for current? What is lambda? Lambda is the resistance per unit length of the loop. Same, this problem only will modify things. So I want expression for induced current in the loop here. Find what to do, how to find out. We know I'm going to go for take help of mutual inductance. So there'll be EMF induced. If a varying current flows in this structure, it's a long wire. How do it will produce EMF induced one? I'll calculate mutual inductance. With the help of mutual inductance, I can go for how to calculate mutual inductance. So first, what we do is like let's calculate the flux linking this structure. Side length of this is L. So what is the flux linking that? D phi equal to B into dA, which is equal to B into L into dx. What is B equal to? Mu naught I due to long y. L into dx. So further, this is mu naught I L 2 pi dx by x. The limit will be A to A plus L. One plus L by A. Okay, there's a flux linking. Mutual inductance, how you define flux linking the coil to the current in the coil. Mu naught L 2 pi log of 1 plus L by A. Okay, this is the mutual inductance. Now, what was the question asked? We have to calculate the induced current. So what is the formula for induced current in the loop? The induced current in the loop should be equal to M into di by dt. What is M? M is a mutual inductance. Di by dt is the current in the wire, rate of change of current in the wire. According to this, it should be equal to M is how much? Mu naught L 2 pi log of 1 plus L by di by dt is I naught. There's the EMF induced. So what is the current in the loop? Current in the loop equal to E loop by lambda into 4L, resistance of the loop. Mu naught I naught log of how that induced current will flow by Lenz's law. It has to be in this direction. Getting the idea? The idea of mutual inductance. See why I am asking you to think like this. I will slowly introduce one by one. I'll slowly introduce all the things one by one. It'll be this one problem is sufficient to understand things which I'm going to explain now. Okay, everyone fine. So there is some sort of EMF is there, no? So what we can replace that loop by a source E loop and also the resistance. So what is the equivalent circuit of this will be? The equivalent circuit. Can we adjust here? The equivalent circuit it will be, there's a I. So the whole circuit, actually, we are supposed to replace with a this will better picture. A student has to go to this level. There is some sort of sources, EMF is generated, a cell and a resistor. Agreed? This is our electronic, like a electrical way of thinking. This is I loop. Just make observation. I'll make some small changes here. Now, shall we bring one capacitor along with the rest? I'll slide down. Now, instead of this, okay, we'll go for, there's a wire. The loop itself contains one resistor and one capacitor. Side length, let it be L. Then a varying current, I'll send it. I want steady state charge across the capacitor. It's a loop. Hope everyone is able to understand. It's a loop, and the resistance of the loop we are showing that let it be R. So I'll write it here. So let it be at a distance. L will take it so that it will become very simple expression for us. I want steady state charge across capacitor. First, we should calculate EMF induced in the loop. So whose help we should take? This particular formula, EMF induced in the loop. M di by dt. I think this will become log 2. EMF induced in the loop should be equal to log 2. So what is the equivalent circuit will be? The equivalent circuit we should go for, I'll do one thing, a loop having resistor, a loop of side length. Is placed nearby a long wire find steady state charge across capacitor. Okay, this is a question that is asked here. First, we will go for equivalent diagram. The equivalent diagram, what it says, there should be a cell. Can we go for the EMF induced across the cell? So there should be the cell, there should be the resistance, there should be capacitance. So from where this EMF we have brought it, so expression for EMF should be equal to M di by dt. This should be equal to mu naught L 2 pi. Yeah, I think we can see completely. Log 2 di by dt is I naught. Hope everyone is able to understand here. Sir, how come log 2? Here length A is equal to L, no? Because of A equal to L, what we are getting is mu naught L by 2 pi, log 2 will get it. And di by dt is what? I naught. Now these are very important, especially for exam purpose. A student must know how to take that help of mutual inductance. So I got EMF induced. Then at steady state, Q infinity should be equal to E loop into C. Okay. So this is a steady state charge. You should not get scared. So many things. Let it be. Some mutual inductance is there. So there'll be EMF induced in cell. So how you determine the polarity of cell? I think by Lenz's law. Flux negative flux increases, differability negative, EMF induced positive. So therefore the polarity of cell is given in this way. Sir, I want current in the loop at any time t. I think we should go for RC circuit, concept of RC circuit. What will be the current in this? At steady state should be 0, no? Please don't get confused here. If it were only resistance, okay. Because of capacitor, now you bring just like that EMF induced is a cell, that's all. Again, it's a pure RC circuit problem with a cell. From where that EMF of cell? Due to mutual inductance. Able to understand now? There's a very basic problem. This can be asked in different way here. Anybody